Understanding dynamic programming.
Dynamic programming is a technique for solving problems by breaking them into simpler subproblems. Two main approaches are tabulation and memoization. Both optimize recursive problems by storing results, but they differ in how and when values are computed. Understanding these methods helps you write efficient code and choose the best approach for your problem.
What is memoization?
Memoization is a top-down approach. It starts with the original problem and solves smaller, required subproblems only as needed. Results are saved, usually in a dictionary or array, to avoid redundant calculations. For example, in a Fibonacci function, each value is computed only once. Memoization is intuitive and easy to implement, especially with recursion.
What is tabulation?
The tabulation is a bottom-up approach. Instead of recursion, you solve all possible subproblems first, usually by filling out a table, then build up to the desired solution. This method avoids the overhead of recursive calls. For example, in tabulated Fibonacci, you fill an array from the base cases up to the nth value. This often leads to faster, more space-efficient code.
Code example Fibonacci sequence.
First, let's look at fib n memorize IH. Fib n is equal to 2n. If n is equal to, return n. If n is equal to 2, n equals n. Table I is equal to table I plus table I plus table. Return table n.
Choosing the right approach.
Choose memoization if your problem is naturally recursive or needs only specific results, as it's easier to implement and only computes subproblems as needed. Tabulation is better when you need all solutions or want the best space and time efficiency. Analyze your problem's structure, recursion depth, and potential for redundant calculations to decide.
Summary.
Tabulation and memoization both optimize dynamic programming, but they use different strategies. Memoization uses recursion and caches results on demand, while tabulation builds solutions iteratively from base cases. Understanding both techniques and when to use each lets you write faster, smarter code for a wide range of problems.